Hey guys, the time's come for us to talk about CDP diagnostics. Now in order to be able to do that, I just want to highlight some things to make sure we're all on the same page with regard to what's happening in our infrastructure. Everything is exactly the way it was based on our configuration from the previous video. However, all I did is I re-enabled CDP on the interface of our given devices. Now, what I want you guys to recognize is this. It's important, and let me adjust this screen just a little bit. What I want everyone to understand is that on R10, Show CDP, we still have all of the information. This is a router. Router configurations and switch configurations default to the same values. Also, Show CDP Neighbors, again, tells me that Cat 10, or R10, excuse me, so the router R10 is connected to Cat 1. And the interfaces that we're using here on our device is that our local interface is 00, and the device or the interface that we're connected to on the remote device is going to be 10. So again, useful information. But what I want to look at right now is the nature of the hello information and the layer 2 communication that's taking place between Cat 1 and R10. Now what I'm going to do is I'm going to bring up a Wireshark session. So let me grab my configuration here, and I'll just simply grab this. And what we have is an example of the capture of the information across the link from R10's Ethernet 0/0 interface. Now, I don't want to look at all the information, so what I'm going to do is I'm going to filter. And I'm going to come in and I'm going to say I want to filter this on the basis of just CDP, Cisco Discovery Protocol. And what we're going to see here is some pretty critical information. Notice we have 1, 2, 3, 4, 5 packets that we've captured, or 5 frames. Notice the destination here. It says it's CDP, VTP, DTP, PAGP, and UDLD. We're going to talk about all of those. The one that I want to focus on right now is CDP. Now, if we also look over here in the information, notice it tells me immediately my device ID is R10, and I'm using Ethernet 00. So we know that R10's Ethernet 00 interface is connected to Cat 1's Ethernet 10 interface. Now, what I want to do is I want to look at this payload, but before we go to the payload, I want to highlight the fact that, remember, if I go to my logical link control section, which is going to be how the layer 2 to layer 1 communications is taking place, the drivers and the communications that are operating with Ethernet, what I want to point out here is, remember, my configuration is supporting SNAP. Keep in mind that if we do not have SNAP configuration or capability on an interface, CDP is not going to function on that interface. Again, just pointing that fact out. But the main area that I want to start paying attention to here is this notion right here, this idea of the Cisco Discovery Protocol information. There's just so much in here that we really need to pay attention to. Notice version 2. That's the nature of the config itself. Also notice my TTL, my time to live, is 180 seconds. So the whole notion here is the fact that we want to keep everything bounded, and remember, these are all link local communications. Now the other part of this is that when we go in, notice it has my device ID. If I come up here, it's going to give me my software version that I'm running, version 15 code. Tells me what my platform is right now. Because of virtualization, it's just showing up as a Unix device, but if this was a 3550, then it would show up, a 3750, it would show up as a 3750. Notice I also have some other values here, the port IDs, and that's going to represent my interface, and it also is going to allow me to exchange things with regard to my capabilities, information that I'm going to be able to exchange. So the idea here is capabilities. Remember, I said that was the notion of what we have. Notice this is telling me it's a router. Does it function as a transparent bridge? No. Is it a source route bridge? Yes, it actually is. Is it a switch? No. Is it a host? No. Is this device IGMP capable? No. Is it functioning as a repeater? No. We have tons of information that's actually being exchanged inside the confines of these packets. The other thing that I want to point out here is notice we mentioned the duplex, and let's also look at the IP prefixes that we have. Let me scroll down here just a little bit. What we're going to see is that we have this idea here of the IP address that we're going to be using, but what I want to highlight here is another protocol that's no longer in the scope of the routing and switching exam. I would go so far as to say it was never really inside the scope of version 4, but I know beyond a shadow of a doubt it's not inside the scope of version 5. And that is ODR, which stood for on-demand routing. And all on-demand routing did is it created a routing table based on the information that could be exchanged inside these CDP packets. And it worked very, very well for hub and spoke style topologies, and it doesn't take a lot of operational overhead. Now, the thing that I want you guys to understand is this. CDP is a great and wonderful tool. However, in the early days of routing, it was possible that if you had so much stateful information that you were going to be maintaining, that with routers that we had, they had smaller amounts of memory, you could quite literally gut your available RAM on your router by maintaining all of this CDP information that we're exchanging. So what I want everyone to understand is that that capability is still there, but the thing is the memory now is capabilities are so high, it's not really going to be problematic. However, in immensely huge layer 2 infrastructures, I guess theoretically the possibility exists that we could actually incur this problem. But you've just seen a small handful of all of the information that is going to be exchanged with regard to these CDP messages. Now, another thing that I wanted to highlight here is let's scroll back up and let's take a look at our frame configuration here. No, it's not inside the frame. Where is it? Is it the Ethernet? Yeah, here it is. Okay, notice here. It's telling me that I have a source MAC address. That source MAC address ends in OA00. Let's take a look at R10. So if I come in here and I say show interface E00, and I want to look specifically for a burned in address, the BIA, we can see right here those last four are OA00. Notation is different. However, the last four hexadecimal decimals values are the same. In fact, this entire range is the same. So that identifies the fact that this came from R10. Now, also bear in mind the destination MAC address. The destination MAC address is right here, and it's that 01000C. That's going to be that destination MAC address. However, what I want you guys to understand is that that MAC address is not dedicated just to CDP. It's a well-known multicast link local MAC address that's going to be used for CDP, VTP, VLAN trunking protocol, dynamic trunking protocol, port aggregation protocol, and unidirectional link detection. So it's not just dedicated to CDP, and it's one of the few times in your studies for CCIE routing and switching that memorizing one value is going to serve you very, very well because it's going to apply to multiple protocols and features that we're going to be running. But this is an excellent example of exactly what type of information is being exchanged, and if you can learn how to interpret this, you're going to be one step closer to being able to deal with any type of embedded packet capture or any type of any type of Wireshark traces that you may receive inside your diagnostics section. I will constantly stress looking at this output, and I will constantly stress looking at this output in an operational environment, because when you see this given to you and you have a problem, I want you to know what it's supposed to look like versus to what it looks like when you're handed it to you in a diagnostic ticket. All right, so again, we'll keep revisiting all the technologies in the form of theory, configuration, and diagnostics, and I'll see you guys in the next video where we're going to be talking about the industry standards link local discovery protocol. See you there. Bye-bye.